Hello, differential equation students, and welcome back to Unit 4. Okay, and so far in Unit 4, we have done 3.3, which helped us create models, and we have done 4.9, which helped us solve those models. And the way we used, or what we did in 4.9, was we solved using elimination. Well, with the test that we just went over, we used Laplace in Chapter 7, and now we're going to do 7.6, which is a system, and now we have initial conditions. Whenever we have initial conditions, we should actually really like using the Laplace transformations. Okay, so we're going to be using these. I'm going to use the same type of video setup that I did for 4.9. Here on the first video, I am going to go through one problem, and then on my next video, I will do a separate problem. I haven't decided whether I'm going to try to mix in a word problem somewhere in here, but I will do 3 examples just like I did for 4.9. So let's get right into it. The very first thing that we have here is a system with x and y as our dependent variables and t as our independent one. This would be a great time to pause the video and make sure you get everything written down. Okay, now that you have it paused and written down, we're going to go through and we're going to solve this. Some general steps, right? We're going to take the Laplace transform of each of our equations, right? We're going to take the transform of each one of those. If I do the top one here, the Laplace transform of my dx dt, well, that is s big X minus x of 0. And then I have plus, sorry, not plus, equals 2, this would be a big Y, and then I have plus e to the t, well, that's 1 over s minus 1, using the Laplace transformation. On the bottom one, I would have s big Y minus y sub, or at 0, equals my 8 with my big X here, minus 1 over s squared. Okay, and we have it transformed, right? At this point, it's kind of like the elimination method. Okay, it's quite a bit like the elimination method, where I need to choose some variables to get rid of. Of course, I think it's worthwhile right now to maybe get this into standard form where I have all the variables on like the left side here. So I'd have s of x, and I have minus 2 big Y here, right, equals this minus x sub 1, well, this would be a 1, right, just a big 1 here. Okay, that's a terrible 1. It's a big 1 here. Okay, so when it's a minus, so when I drag it across, I would have equals 1 plus 1 over s minus 1. Then down here, similar type of thing going on. This is a big 1 here. So I have, now I want to put this in an order that works for me. So negative 8 big X plus s big Y equals, move the 1 across, and then I have minus 1 over s squared. So you can see that I put my independent variables on the left here, and then I put the s variables over here on the right. Okay, well, after I get it to here, we need to eliminate a variable. When I'm looking at it, you know, it doesn't look terrible maybe to just go after, well, last time in 4.9 I went after the x's right away. Maybe here I'll go after the y's. So what does this y up here need? Well, it needs this s, so I'll multiply this one by an s. This one down here would need a 2. I don't have to do the negative because one of them was positive and one was negative. When I multiply this through, I'd have s squared big X minus 2s big Y equals s plus s over s minus 1. This bottom part, I would have a negative 16 big X plus 2s big Y equals s minus 1 over s squared. Okay, and I feel like I'm ready to add these. Of course, if I've done this right, these should cancel out, which they do. I have s squared minus 16, and that all gets multiplied by this big X equals, now here, a little bit of side work, like if I take the top here, this top part over here, and I get common denominators, I would have an s squared plus s, right, minus s. Well, here, I don't want this to be confusing. Let me write all my work out. For my fraction, right, I have to do an s times s minus 1 over s minus 1 plus s over s minus 1, which should give me s squared minus s plus s all over s minus 1. Same type of thing going on the bottom part here, right? That would become s times s squared over s squared minus 1 over s squared, which would give me s cubed minus 1 over s squared. Okay. And as I'm working through this problem, I can actually see a mistake I made, which I'm sure you guys actually found here. Okay. Here's my mistake, right? This 2 came in times this, and whatever reason I wrote this as an s. That's actually a 2. Right? That's a 2, which is going to change what this thing over here is, because now no longer is this an s here. This is supposed to be a 2. That's a 2. And then I'll have 2s squared minus, oh, and I also, it looks like I forgot to take this 2 over here inside this one, so it'd be a minus 2 over s squared. Okay. Common mistakes, just kind of forget that right side. So really, this is kind of a little bit messy, but here I'm adding these, right? These whole things, right? That's how I got this piece down here. Well, that means I'm taking this one plus this one, which I can simplify the top one maybe a little bit. That's just s squared over s minus 1, right? And then I would have plus 2s squared minus 2 all over s squared. Okay. And now what you can see is I'm actually to a spot where we've seen this type of stuff before. This right here we saw all back in Unit 3. We saw this all back in Unit 3. A couple different ways to tackle this. One, I could make this whole right side into a single fraction, right? I could do that. Or I've seen some of you divide out this s squared minus 16, which would become s squared over s minus 1 times s minus 4, s plus 4, plus, I do see this 2, and I could factor it out, but I think I'll just leave it for now. I have an s squared times s minus 4 and an s plus 4. Now, you have a couple options here. One, you could make one giant fraction out of this, and that's how I kind of showed it inside the notes. Or you could split them up. What will happen, though, is you'll get a couple different e to the 4t's and e to the negative 4t's, and then you'll have to combine those later. So it's really completely up to you how you want to go about the problem. I think for the first video here, maybe I will make one giant fraction. Okay, make one big fraction here, which means this one here is missing an s squared, so I'd have to multiply the top by s squared. That'll give me an s to the 4th. And this section over here is missing an s minus 1, so I'd have to multiply the top by s minus 1, which would give me a positive 2s cubed, a negative 2s squared, a negative 2s, and a positive 2. And then that whole thing now is over s squared, s minus 1, s minus 4, and s plus 4. Okay. And from here, even though it doesn't feel like it, we're in the home stretch. We really are, because this is a big X, and I know the inverse Laplace of that is just going to be my little x. I just have to take this and break it down using my partial fractions. So I have a over s plus b over s squared plus a c over s minus 1 plus d over s minus 4 and plus e over s plus 4, right? Which creates this auxiliary equation, right, of, let's see, how do I want to write this? I have s to the 4th plus 2s cubed minus 2s squared minus 2s plus 2 equals, a would need another s and all of the other ones. B would need just the s minus 1, s minus 4, and s plus 4. Of course, there's a plus sign here. And then I would have C would need s squared, and then s minus 4, s plus 4. It's kind of a terrible plus sign. Let's get rid of that. And then I have to add in my D, which would need s squared. That'd be an s minus 1 I would need, and an s plus 4. And finally, E would need an s squared, s minus 1, s minus 4. Okay. And hopefully, because I have a bunch of unique different ones here, this should be rather painless. Like if I let s equals 0, well, what would happen up here? Everything would go away except for a 2. Should equal what happens here? Well, this a part gone. B still has something. C would gone. D is gone. E is gone. So all I have left is b times, okay, this would be a negative 1, so I'd have b times, let's see here, negative 1 times negative 4 times 4, which then makes 2 equal to 16b, which means b is equal to 1/8. Okay, and then we just keep going, right? If s equals 1, then I would have up top here, I should get negative 15. I'm sorry, that's not right. I think that just ends up being 1. Let's double check. So 1 plus 2 minus 2 minus 2 plus 2. Well, these go, yeah, it's just a 1 equals. Now everything else is gone. It's got this gone, but C's isn't going away, so I have to mess with C. So I have C times 1 times negative 3 times 5, which makes 1 equal to negative 15C, which means C is equal to a negative 1/15. Okay. S equals 4 would be next. And if I put x equals 4, I think I'll let you do this math on your own here, but this does end up being 346 is equal to 384d, which then I get to be d equal to 173 190 seconds after I do a little bit of simplifying. And s equals negative 4 would yield that 106 equals 640 E, which then implies that E is equal to 53 out of 320. The final one, I need to find out what, let's see here, I got B, C, D, and E, which means the only thing left to find is A. Well, when I look at A, it is the only, or let's see, we'd have A would be 1, 2, 3, 4. This would have an S to the 4th. So maybe I'll use S to the 4th power implies, well, what's the coefficient on s to the first or fourth power? That's a 1. So it should be 1 equals a for sure because it's in there, right? Are there any others? Fourth powers. Well, this one would have a fourth, right? So would D, so would E. So I get A is equal to A plus C plus D plus E. And plugging in all of the numbers and working them down through, I think I end up getting that A has to be 0. Okay. Of course, how do I do that? Well, I take the numbers up above that I had before. Writing this thing out now, I have x is equal, that's a big X, is 0 times 1 over s plus 1/8 times 1 over s squared minus 1/15 times 1 over s minus 1 plus 173 192nds times 1 over s minus 4 plus 53 320ths times 1 over s plus 4. Let's see here. This one here represents the A spot. This one here represents the B. Here's my C, D, and E. So I feel like I got them all. Now I just take the inverse Laplace. Well, that becomes x of t equals, well, this is gone because of the 0, so that's just 1/8 t minus 1/15 e to the t plus 173 170 or 192nds e to the 4t plus 53 320ths e to the negative 4. Okay. Now the question is, how do I go from here? All right, I got half the answer basically. Well, remember what we did before. We go back up to the problem, right? And we're looking for one of the equations that we want to mess around with here. And I think, you can go about it any way you want. But I know that I have x, right? So finding this, which is x prime, isn't hard. And then I just have a single y in there. So maybe I'll use that equation. Which, how would I write that? That'd be x prime equals 2y plus e to the t. X prime equals 2y plus e to the t. Right? And I'm solving for, I know I'm going to have to end up solving for y, so I might as well just do that now. So that'd be x prime minus e to the t. And technically, this whole thing would then have to be multiplied by 1/2, and that would give me y. And from here, all I need is the derivative of my x prime, which I do have up here, so I just find the derivative real quick. That's 1/8, right, minus 1/15 e to the t plus 173. If I multiply by 4, that goes into 192, and I think it'll cut it down to 48, e to the 4t, and then I have a minus 53. Yeah, again, I think that 4 will go into that, so that'd be minus, I'm going to drop it down to an 80, and that's e to the negative 4t. There's my derivative, and I'm taking this purple part and I'm plugging it in now to the equation. So this is equal to negative, or 1/2 times, okay, my purple part, that's 1/8 minus 1/15 e to the t plus 173/48 e to the 4t minus 53/80ths e to the negative 4t, and then I have my minus e to the t here. Combining what I can and multiplying this 1/2 through at the same time, I think I get 1/16 plus oh, I don't want that to be a plus, minus 8/15 e to the t plus 173/96 e to the 4t minus 53/160 e to the negative 4t. And there I have my y of t. This is the second part to my solution, paired of course with this blue part up here. Okay. And there you have your first problem. Yeah, it took 20 minutes to get through that problem. Quite a bit of talking. I showed all the decompositions of fractions again. Make sure you're going back and you really understand that problem before you move on to the second video.